Hello students, welcome to the chapter Inverse Trigonometric Function, lecture number 1. Dear students, this is a second chapter in the mathematics syllabus for PU2. Let us start this chapter with the introduction part. Dear students, before we begin the study of inverse trigonometric functions, here are a few concepts that one needs to get clarity about. That is, what is one-one functions? What is an onto function? What is a bisective function? Dear students, in the chapter Relations and Functions, we have discussed these types of functions, one-one, onto, bisective. Let me take one more time the discussion about these two types of functions. For that, let's consider a set A with the three elements. This is a set A with the three elements x, y, z, and another set B with the elements 1, 2, 3. Suppose f is a function from A to B, then when do we say that f is one-one function? Try to recall. One-one function means distinct elements of domain are mapped to distinct elements of codomain. It means, as you remember, distinct elements of domain have distinct elements in the codomain. That is called one-one function. Let me relate x to 2, y to 2, z to 2. Do you think that this is one-one function? No, because x, y, z are different elements, but they have same image. Therefore, this is not one-one function. Now let me take x to 1, y to 2, z to 3. Clearly this function is one-one function because x, y, z are different, even they have the different images in the codomain. Hence this function is one-one function. When do we say that a given function is onto? That is also a question. When we say that a function is onto, recall onto definition. Every element in the codomain has a pre-image. Every element in the codomain should have a pre-image, or in other words, codomain is equal to range of the function. Hope you are understanding, and also you are remembering, and also you are recalling. Every element should have pre-image, or codomain should be equal to range. Now let us check 1, 2, 3 are the elements in the codomain. Are they having pre-images? Definitely they have the pre-images. 1 is having x, 2 is having y, 3 is having z as pre-images, or codomain is 1, 2, 3, even range is also the set 1, 2, 3, hence range is equal to codomain. This function is onto function. Let's consider now the trigonometric sine function defined from real number to real number. Take its graph. Hope you know that sine function, the graph of sine function, and the range of sine function is -1 to +1, closed interval. Now, what do you think about this function? Is it one-one function? To check that, let's use the parallel line test. Dear students, there is a test. Graphically, you can say whether the function is one-one or not. That is called as parallel line test. What is that parallel line test for one-one? A line parallel to x-axis drawn on the graph must meet the graph only at one point. Dear students, you need to draw a parallel line to the x-axis that must meet the graph at only one point. Then the function is one-one. If the line parallel to x-axis meets the graph more than one point, that is not one-one function. Let me take a parallel line to the x-axis. This is a line parallel to x-axis. You can observe this is going to meet the graph more than one point. You can see the circles. At these points the line is meeting the graph. Do you think that this is one-one function? No, it fails the parallel line test. This function is not one-one function. Now, can this be an onto function? Again, for this, take the help of parallel line test. What is a parallel line test for onto? Concentrate. A parallel line test for onto function is any line parallel to x-axis drawn on the codomain must meet the graph at least at one point. Dear students, you need to draw a line parallel to x-axis that must be on a codomain, that must meet the graph at least at one point. At least means minimum at one point it should meet the graph on the codomain. Now you can check a line parallel to x-axis. Is it going to meet the graph? No. Hence, sine function is neither 1, 1 nor onto function. Sin x function is a function which is not 1, 1 and not onto function. I am taking trigonometric functions and verifying whether they are 1, 1 onto or not. Let us consider another trigonometric function, tan function, defined from S subset of R to R. Again, consider its graph. As you know, in first PUC trigonometric functions, graph of trigonometric functions, it is a graph of tan function. Is this 1, 1 function? For this, check using parallel line test. Draw a line parallel to x-axis. Is the line meeting the graph at only one point? No, it's meeting the graph more than one point. To verify it, tan is an onto function. We use parallel line test. To use parallel line test, draw a line parallel to the x-axis on the codomain. You can observe a line parallel to x-axis. Hence, tan x function is an onto function, because parallel line test for onto is a line parallel to the x-axis meet the graph at least one point. At least one point. Here you can observe a line parallel to x-axis meeting the tan function, means its graph at least one point. Therefore, it is onto, but it is not 1, 1. Having clarity about 1, 1 and onto function, let's now see what is a bisective function. A function is called bisection if it is 1, 1 and onto. As you studied in relations and function, bisective function is a function that must be 1, 1 and onto. After defining the bisection, we can now talk about the inverse of a function, because only bisective functions possess the inverses. Only bisective functions gives us inverse functions. Then what is inverse function? Corresponding to every bisection, f from A to B, you can observe the diagram also, f is a function from the set A to the set B. There exists another bisection, that is g from B to A. Please observe the diagram. There is a function g from the set B to the set A, defined by g of y equal to x, g of y equal to x, if and only if f of x equal to y. Such function g from B to A is called inverse of f from A to B. It is denoted by f inverse. F to the power minus 1 means f inverse. Dear students, inverse function means, first of all, there will be a function f from A to B, and we define a reverse from B to A to say that inverse, that must be 1, 1 as well as onto, then only inverse exists. From the definition of inverse of a function, it is clear that inverse of a function exists if and only if it is a bisection. Yes, definitely it is a bisection, that's why inverse exists. But from the earlier two examples, we know that sine and tan functions are not bisective. Definitely, as we discussed sine and tan functions, sin x function was not 1, 1, not onto, hence sine was not bisective. Tan function was not 1, 1, but onto, but it is not bisective. So, finally, what we can say? No trigonometric function is a bisective. Not only sine and tan function, students, all trigonometric functions are not bisective function. If the trigonometric functions are not bisection, then what are we going to speak about the inverse trigonometric function? Dear students, try to understand. If trigonometric functions are not bisective, then they will not possess the inverse. If they won't possess the inverse, then there is no use of talking about the inverses of trigonometric function. Are you understanding? Inverse trigonometric function is a chapter, but trigonometric functions are not possessing the inverse. Then how to discuss the chapter is the question. For that question, we need to redefine trigonometric functions. We need to redefine trigonometric functions. For what reason we should redefine? To make them bisection, to make them bisective functions. Why we have to make them to become bisective functions? Just to have the inverses. So what is a very important concept here? We need to redefine trigonometric functions to make them bisection. Then how do we redefine the trigonometric functions is the question. We redefine the trigonometric functions by restricting their domain and codomain. We should restrict the domain and codomain of the trigonometric functions, then we can get the redefinitions. Then definition of sine inverse and cos inverse function, because we are talking about the inverse of sine, inverse of cos, inverse of trigonometric. So the notation is sine inverse, cos inverse. Let us have the discussion on that. Let us consider sine function defined from R to R. It is a original sine function from R to R. Sin x is from R to R is a function. Graph of f of x equal to sin x is a graph. Now, is this bisective function? For that, I should check 1, 1 and onto. Here a line parallel to x using parallel line test. A line which is parallel to x axis meeting the curve at more than one point. Absolutely it is not 1, 1 function, or more than one elements in a domain have same image in the codomain. Therefore, sin x is not 1, 1. And onto. As the range of sine function you know minus 1 comma 1, the closed interval minus 1 comma 1, and codomain is equal to set of real numbers. They are not equal. Therefore, every element in codomain does not have a pre-image. Therefore, this is not onto. Sin x function is not 1, 1 and not onto. Then this is not bisective. Now, very important. This is not bisective. We understood this is not bisective. Now, to make sine function a bisection, we restrict its domain and codomain. Very important discussion, students. Because of sine function is not bisective, we are restricting the domain and codomain of sine function. How to restrict the domain and codomain? See the curve. I have restricted the curve to some points minus pi by 2 to pi by 2 I have taken. This is the restriction of domain. Now you can check parallel line test. The curve, the straight line parallel to x axis meeting the curve at only one point. Therefore, this is 1, 1 function. So, why it has become 1, 1? We have restricted the domain. Now, we will define function sin x as sin x from where to where? You can see the x axis, that is the domain. Y axis is a codomain. X axis is from where to where? Minus pi by 2 to plus pi by 2 is a domain. And to what? Y axis minus 1 to plus 1 is a codomain. This minus pi by 2 comma pi by 2 we call it as principal domain. To draw the graph of sine inverse, of course we drawn the sin x function. Now I should take its graph of inverse. Graph of sine inverse function, we take the reflection about the line y equal to x. Now I have to reverse x axis as y axis as x axis. Now you can see the diagram here. Pi by 2 went to the y axis, 1 came to the x axis. Minus 1 went to the x axis, minus pi by 2 came to the y axis. Exactly interchange of domain and codomain. This is called inverse, reverse. So now, inverse of y equal to sin x is sin inverse y. Notation you please observe, sin inverse y from minus 1 comma 1 to minus pi by 2 comma pi by 2, because exactly we reversed. You can observe sin x is from minus pi by 2 comma pi by 2 to minus 1 comma 1. The reverse of this is minus 1 comma 1 to minus pi by 2 comma pi by 2. This is trigonometry. This is inverse trigonometry. This exists only if sin x equal to y. This is the redefinition of sine function. Dear students, sin x from minus pi by 2 comma pi by 2 to 1 2 minus 1 comma 1 is a redefinition of trigonometric function to have inverse. Let us consider cos function defined from R to R. Exactly like previous discussion, cos x is from R to R. Graph of f of x equal to cos x. See the graph. Is this a bisective function? Definitely no, because of parallel line test, not 1 1. That is, more than one elements in the domain have same image in the codomain. Hence cos x is not 1 1. What about onto? Range also minus 1 comma 1, but codomain is R. They are not equal, or you can say every element in a codomain does not have a pre-image. Therefore cos x is not onto. Overall it is not a bisective. So to make cos function a bisection, we restrict its domain and codomain. As we discussed earlier, we should restrict the domain and codomain of cos function, then that will become bisective. So the restriction will be, you can observe, I have restricted the domain from where to where? From 0 to pi. I have restricted from 0 to pi, and you can observe the parallel line test. Parallel line is not meeting the graph more than one point. It is meeting at only one point. Hope you are observing that. Hence it is 1 1 function. So we will define a function cos x as cos x from restriction of domain from where to where? 0 to pi. See the graph here. This is a graph. The domain is from 0 to pi. And the range of course minus 1 comma 1. This is called redefinition of cos x function to make bisective. To draw the graph of cos inverse function, we take the reflection about the line y equal to x. Change the domain into codomain, codomain into domain. That is called reflection about y-axis. You can observe the replacement here. Now we get the inverse of cos function like this. So inverse of y equal to cos x is cos inverse of y from minus 1 comma 1, exactly reverse of cos x, minus 1 comma 1 to 0 to pi if cos x equal to y. So this is called inverse of cos function, and it is 1 1 onto bisective. Thank you students. This is just introduction part of the inverse trigonometric functions chapter. In the next video, I'll come with some more discussion of inverse trigonometric function. Thank you.